Welcome to Programming with Python session 8. First of all, let us understand something about where you get these resources, right? So, this is our website. You can go through this website and you can understand what are all the courses that we offer, and you can contact us in any of these modes. And coming to resources, which is the most important thing, you have the resources available here for the past 7 sessions. Whatever the learning resources that we have been using, all these have been posted here. You can download them for free and you can become programming experts. All right, by the end of this session 8, we will also have material that we use in this session posted at the same place. So please make a note of this website, technolearnit.com. With that, let us get into our session. Control over iteration using break. Before we jump on to this topic, I'm going to show you something using some Python program, just as a recap. So, say, what is iteration in Python? Iteration can be achieved using for, and the other one is while, correct? So, if we are using for, we'll be using some variable in general, and you are going to use range function, and range function would take three different arguments, out of which one is mandatory, right? And I'm just printing the value of I for now, separated with a single space. All right. So for is an iterative structure. I just wrote this program, and you can see the output coming out 1, 3, 5, 7, and 9. Why is that? It's because the range function, the very starting point is 1, and it is the end value, which is exclusive. It will never exceed this, right? So the range function continues to generate numbers 1, and this is a step value or the increment value. So then 3, 3 plus 2 is 5. 5 will be always compared against 11, whether 5 is smaller than 11. Yes, it is. So it can go ahead and generate one more number, 7. 7 plus 2 is 9. 9 is also lesser than this. 9 plus 2 is 11. 11 less than 11 is false. So it comes out. Hence, the output is 1, 3, 5, 7, and 9. This is one iterative structure. The other iterative structure is while. When you are using while, you can start the variable with some value, and then you can use that variable in your condition, and you can do the same operation here as well. I am printing the value of I, and I am also separating the output with a space. And not only that, it is our job to also make sure the loop variable changes in some means. So I'm now going to comment out this code. Sorry. And I'm just going to run this portion of iteration, which is while loop. So it produces numbers 1 to 10. And if I am supposed to produce numbers with a difference of 2, I can increment I value by 2 and let us run this one more time. As you can see, you can produce output like this. So these are the two iterative structures that are available in Python. Now, what is that we are going to talk about today? It is about same control structures, but we need to have more control over them. In what sense? Let us take some examples to understand it. What is break? Let us look at some examples, right? So when the input given to your program is 5, the expected output is 1, 2, 3, 4, 5. Make sense? When the input is 12, the output expected is 1, 2, 3, 4, 5, 6, 7, 8, and 9 to 9. Okay. When the input is 25, the output is the output expected is 1, 2, 3, 4, 5, 6, 7, 8, 9. What does it mean? Or how what is that you can derive from these three examples? Doesn't matter whatever the input is, especially when it is a two-digit number, always my output should stop at 9. Correct? When the input is 5, for example, the output is 1, 2, 3, 4, 4. The expected output is 1, 2, 3, 4, 5. That means as long as the user given input is less than 10, you can just generate the natural numbers up to n. And if n value is greater than 9, just stop at 9. Right? That is a pattern that you have observed. How do we achieve this? First of all, there is an iteration involved in this. So let us go ahead and code it. Right? So what if I use for loop to generate that? Right? So obviously the user has to provide the input. I don't know where to stop. So n, I read the input from the user into the value of the, correct. Once I read it, I can go up to, say for example, I put n here and I just default step value to 1. And what would be the output for this piece of code, right? Focus on only on the active code here. This is active code. And as you very well know, if the input is 5, the output is 1, 2, 3, 4. Why? Because the n value is exclusive. The end value is always exclusive in range function. If you also want to include 5 in your output, you need to use n plus 1 in your range function. Correct? So, you can go ahead and you can pass 5 as input. If you run the same program once again with an input of say 15, the output produced is 1 to 15, all the natural numbers. However, the expectation is just to stop over here. I don't want to generate any two-digit numbers. Correct? Hence, what can I do? One way to achieve this is you can check here itself. Leave n as n only if n is less than 10. Otherwise, limit it to 10. And in this case, I would prefer to use n plus 1 because so that I can use n directly here instead of n plus 1. Makes sense? It's up to you whichever you want to use, but if you want to go with this, you have to still use n plus 1 over here. All right. How does this work? User entered, for example, 5. N will not change because 5 less than 10 is true, then n value will be same as 5. And this loop executes for 5 times and it keeps producing the output of 1, 2, 3, 4 and 5. That's all. What if the input is 12? This condition is false because 12 less than 10 is false. Then 10 would be assigned to n, right? Sorry, yeah, 10 would be assigned, sorry, we should have just 9 over here. 9 would be assigned to n and the numbers produced would be 1, 2, 3, 4, 5, 6, 7, 8 and 9. That's all, correct? So let me run this program for you with an input of 12. So you see the output produced is up to 9 only, right? If I run this program once again for an input of 100, it produces the same output because I just wanted to generate only single digits. No, that is how I am controlling where to stop the iteration. Before I even enter into the iteration, I am adjusting the n value accordingly, right? And now, how can we achieve this without using this adjustment, right? So if you just continue to go like this, right? So the value of I keeps increasing starting from 1 and it doesn't stop at all until it reaches the end value. Hence, what we can also do is you can add a condition. If II has exceeded 9, what should I do in this case? That is where break comes into picture. Break is a keyword in Python, and this break stops the leftover iterations or remaining iterations, and the control comes directly out from the loop. So I may print I am done, just to show you how the control flow would be. So to begin with, input is 5, assume. This loop runs for 5 times. Nowhere I value exceeds 9. So this break won't get executed. And always it keeps printing I value, changed value of I, where 1 is printed, 2 is printed, 3 is printed, 4 is printed, 5 is printed, and the moment I becomes 6, you come out of this loop completely and the output I am done will be produced. Let us run this for an input of 5. So as you can see, numbers from 1 to 5, digits from 1 to 5 have been printed, and finally you also see I am done. I am done. All right. Now, the same program, what if the input is 15? This loop starts with 1, but this condition, if condition is false, 1 greater than 9 is false, so 1 is printed. Then I becomes 2, 2 greater than 9 is false, 2 is printed. I becomes 3, 3 greater than 9 false, so it comes and prints 3. This break is a statement that gets skipped. And 3 is printed, 4 is printed, 5 is printed, 6, 7, 8 is also printed. When it comes to 9, 9 greater than 9 is false. So break is skipped, 9 is printed. Then I becomes 10. 10 greater than 9 is true. This break gets the control completely out of this for loop irrespective of how many iterations are remaining. Doesn't matter. This break will get the control completely out of the loop in which it is written. So you come out to this place and there you see I am done. I'm going to run this program for you for an input of 15. As you see, the output is just up to 9 and finally you see I am done. I'm running this one more time for you for an input of 100. As you can see, all the digits 1 to 9 produced and finally it prints I am done. Alright, this is how break statement allows you to get more control over your iteration. In general, when you write an for loop using range function, it keeps generating the numbers again and again until it reaches the stop value. But in between, if you want to do something special, especially when you want to come out of that loop completely without executing all the iterations based on some condition, then you can use break. So what is this break going to do in Python? Break is a keyword that helps in terminating the iterations of a loop, generally based on a condition, and the control comes out of that loop and continues to execute rest of the statements in the program. All right. What if I have to do the same using while loop? It's exactly same thing, right? However, you can see some differences, right? So no difference in reading the input. So you read the input, you start your loop, check the condition. What is your condition? If II is greater than 9, it's the same break statement. Otherwise you print and you of course increment by 1. Increment the loop variable by 1. Let us run this program for an input of 5. It produces all the numbers. Something wrong. Let us go and check that. I is 1, I is less than, sorry about it, I need to use n no. I have to go up to n, inclusive n, so it should be equal to less than or equal, right? So let me run this for an input of 5. So as you can see, the output is 1, 2, 3, 4, 5. Let me run this same program using an input of 100. As you can see, it produces only single digit numbers as expected. So this is how you can use break statement within a loop, right? You can use break statement within a loop to bring the control, program control completely out of the loop even before the total number of iterations is not executed yet. That's why generally break statement will be associated with the condition, and based on the condition. Only if the condition is met, you will come out of that loop intermittently and continue to execute rest of the statements in your program. This is how you can use break statement in your program. All right. With all that said, let us move on to the same piece of coding, the same thing that I have just shown you, right? So you read the value of n and you adjust the value of n if required. As long as n is less than 10, just make n as n plus 1. Or if n is greater than or equal to 10, just to store 10 in n. That is where you are adjusting n value. And then start range value. And you see, I just used the end value as n but not n plus 1 because in the adjustment itself I have taken care of updating n with n plus 1, right? And then Every time you print the value of I and then continue on the same line using end equal to space. Using these 4 lines of code, you can produce this kind of output. And if you have to understand how this executes or how this code works, assume that the input is 5, n value is 5. Check the condition on statement number 2. 5 less than 10. Yes, 5 is less than 10, which is true. Then n plus 1 is what gets assigned to n. N is already 5. 5 plus 1 is 6. Now n becomes a 6. Now you get into the loop. Loop execution starts from 1 and goes up to 5 because 6 is exclusive, right? So I 1 is printed, but you will remain on the same line. I becomes 2, 2 printed, you remain on the same line. 3 printed, you remain on the same line. 4 printed, you remain on the same line. 5 printed, you remain on the same line. II becomes 6. Now the condition is false. The range is not going to generate any further numbers. You come out of the loop. And since there are no more statements left in your program, program terminates. The output is 1, 2, 3, 4, 5, as you see here. What if the input is 12? Right? If the input is 12, 12 less than 10, the condition on line number 2, 12 less than 10 becomes false. So what is there in else? 10 is there. So 10 is what assigned to n. Now n becomes 10 from 12, right? You are limiting the value of n to 10 once it exceeds 10 or once it exceeds 10. So again, I value starts from 1, goes up to 10, right? But 10 is exclusive, right? That is how it keeps generating numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. And once II becomes 10, it comes out. That is how this piece of code works, and it produces output as what you see here. The same thing, if you want to use break statement, this is what I have just shown you exactly. You read the n value, you start your for loop. There is no need to adjust n by yourself in the range, but make sure you go up to n plus 1 because n is exclusive. End value is exclusive always. If n value is greater than 9, break. Means don't go with further iterations. Quit from the loop. So break is a statement that allows you to quit from the loop at any point of time. Generally, break is associated with a condition. Once that condition is met, you will quit from the loop. Okay. If not, if the condition is false, if condition on line number 3 is false, break statement would be skipped. And then print is what it's executed. And that is how you can see numbers or the digits starting from 1 going up to 9. The moment I becomes 10, 10 greater than 9 is true, then break statement on line number 9 would be executed. That is how you terminate your program by the time you see all the digits printed on the screen, starting from 1 up to 9. Make sense? So using this break statement, you will get more control. You can have more control over your iterative structures. All right. Let us look at another example. You see, input is 1. There are multiple inputs. You see that? So in this example, user has entered 3 numbers and the expected output is 9. How is it 9? All right. The first input is 1, second input is 8. Sum of these two is 9 and the third input is -1. That is where I indicate that -1 as end of the input and I don't account for -1. And by that time, whatever the accumulated sum is, that I'll print it up. Let us look at another example. You see here, it's the same program, of course, but this time it reads four inputs, and the five last input is negative, so it won't be considered into your sum. With that, the sum would be 4 plus 18, 22, plus 21, 43. So the expectation is to see 43 as output. That means your program has to be capable of reading any number of inputs. In the earlier case, you have just passed three inputs. In this case, you passed four inputs. That means you don't know how many inputs user is going to enter. What if user enters negative value as a first input? There is nothing to compute, and the sum, whatever the sum, you should treat it as zero and you should just produce zero. You get it? How do we achieve this? Let us get onto the code. Let us achieve it with while loop, right? So you don't know how many values user enters. So you can ask enter the values to sum, and you can here mention negative number to it. What does it mean? You enter as many number of values you want to enter, but if you want to stop the process at any point of time, press enter any negative values what you are saying, right? This is only print statement for now because you're not reading any input at this point of time. So you just write a output statement. Then do you really know how many values user is going to enter upfront while writing the program? No, it is all up to user at runtime. So you need to have a loop. Generally, these are called odd loops. You will not know upfront while writing the program how many times you need to iterate. So we use while true. While true. True is always a Boolean true. So it means that the condition will always become true. And what is it you want? This is a place where you can read the input. What is that input? You can read the input into n, treat it as input. Yes, you read, and you need to find the cumulative sum. So have sum assigned to 0, and say you write a statement sum equal to sum plus n, right? But are you going to add each and every input that user enters? Not really, right? Because you are going to sum up only if it is positive. So what will you do if the user given input is negative? How will you know if the user given input is negative? Any input that is lesser than 0 is a negative value. So if n is less than 0, what shall I do here? I should just simply do a break, meaning that is my indicator stating that user has entered a negative number, and that means he wants to stop the process of passing in more and more input, and that is where you use break over this, right? And once you do a sum, once you compute the sum, right, the program control will go back because it is an iterative structure. Condition is true forever. So it again waits for user input. It reads input. It checks whether it is negative. If it is not negative, then it just accumulates it to your sum. Finally, you need to just print sum. Because if you observe the output, it's just one output that is expected. Whatever is sum you have computed so far, you can print it out. And look at this. The print statement is outside of this loop. So you're going to print only once. It's not an iterative process. Read this. Look at this. See, enter the value of enter the values to sum up. Okay, there is a typo. I'll correct it. So I enter. Sorry, I should not really do it over here. I'm 1 second. Enter the values to be December. Okay, just enter a negative value is what you lost. This is just a statement. It doesn't really need to read the input at that point of time. And this is a place where you keep reading the input, right? And now let us run this program. All right, I enter 1, I enter 2, I enter 5, I enter 8, I enter 2 once again, I enter 9, and I decide to stop here. How many inputs did I provide already? To sum up, 1, 2, 3, 4, 5, 6, correct? Yes, I want to stop here. Give any negative number, I just give minus. You see, program has stopped the iterations and the sum of these elements. 1 plus 2 is 3, 3 plus 5 is 8, 8 plus 8 is 16, 16 plus 2 is 18, 18 plus 9 is 27 is what you see here. What if I want to run the same program once again? And this time I stop here itself. I decide to just only pass two inputs. So yes, you can do that, right? And the sum of the first two inputs, because these are only positive numbers, no? That is what your program has computed and printed. And it may not be -1 only to terminate your program the way you have written it. So what if I enter 20, 30, 40, and of course 45, and I just want to stop here by passing -6. Any negative number you pass. So far, whatever the positive numbers that have been provided as input, their sum will be shown here. That is what your program is going to do. Interestingly, while writing such programs, you will never know how many inputs user is going to provide. That's why these are called odd loops. Generally, odd loops will be implemented using while true statement. While true. Okay. So while true, and you do something over here, but make sure you use a break statement so that your loop will not execute forever. A loop that executes forever is called infinite loop. And I'll show you how to build infinite loop and how your program behaves if you have an infinite loop over there. Correct? So every time what you are doing, you are reading an input, you're checking whether it is a negative number. If it is a negative number, you stop. That's all. You terminate your loop. If it is not a negative number, go and sum it up, add it to the sum, and then continue to the same. Read the next input, check if it is negative. If it is positive, add it to the sum. If it is negative, just stop the process of reading the input. And finally, whatever you have computed so far, print it as output. That's all. So this is called odd loop. Okay. Odd loops are very helpful while writing some special programs like menu driven programs. Okay. So you needn't really know how many times your program has to iterate a piece of code in your program, right? So that is where you will be using while true statement, and you use break statement along with some condition, and the condition may vary from program to program, requirement to requirement, right? All right. Now, this is all what we have achieved. And if you look at the code now, it's the same thing that I was showing you. You can just give this as a statement. You start with some zero and you write while true and keep reading the input as integer and just check if it is less than zero, it is negative, if it is negative break. Otherwise, just go ahead and add it up to sum and finally print the value sum. Right? So using these 8 lines of code, you can achieve this. All right. The next one is to print factors. Okay. What are factors of 6? 1, 2, 3, and 6 itself. Every number is factor to itself, and 1 is factor to itself. right? So how do you decide that 1 is factor of 6? How do you decide if 2 is factor of 6? How do you decide 3 is factor of 6? How do you decide that 4 is not factor of 6? Right? So what is a factor in the first place? Right? What you can do is you can divide the number 6 with 1. What is the remainder? You have to look at remainder. When you divide 6 by 1, the remainder is 0. And when the remainder is 0, it means that 1 is factor of 6. Go to the next number, which is 2. Divide 6 by 2. Again, you get a remainder of 0. That means 2 is a factor of 6. Go to the next number, 3. Divide 6 by 3. Remainder would be 0. It means 3 is factor of 6. Go to the next number, 4. Divide 6 by 4. You get a remainder of 2, which is a non-zero value. That means 4 is not factor of 6. So don't print it. Go to the next number, 5. Divide 6 by 5. The remainder is 1. As long as remainder is a non-zero, don't print that because that number is not factor of your 6. Go to the next number, 6. Remainder would be 0 when you divide 6 by 6. That means 6 is factor to itself, right? Obviously, any number is factor to itself. Once you reach the given input, stop over there. Why? A factor cannot be greater than the number itself. So you not go with 7, 8, 9 and all. Stop over there. This is how you find the factors and print them out. 18. What are the factors of 18? 1, 2, 3, 6, 9 and 18. These are the factors of 18. What are the factors of 7? Just 1 and 7. How did I decide that? I divide 7 by 1. Remainder is 0. So 1 is factor of 7. I go to the next number 2. I divide 7 by 2. But remainder is non-zero. The remainder is 1. Don't consider 2 as factor of 7. Go to the next number 3. I'm just generating the natural numbers, and every time I take one natural number, I divide 7 with that natural number. I look for the remainder. If the remainder is 0, I print that. If the remainder is non-zero, I just simply move on to the next number. That's what I'm going to do, right? All right. With all these three examples, how do you achieve this, right? So it's quite simple. As I said, you just need to generate the natural numbers. So you just have to start from 1 and go up to number including. So n plus 1 is the end value for n. And every time you divide the number n by current value of ii and look for the quotient. To look for the quotient, you have to check modulo division operator and you have to check whether the remainder is 0. That is why I'm going to add this condition. If n modulus ii equal to 0, what does it mean? It means ii is factor. So go and print it out, right? So this piece of code is enough to print the factors of a given number n. Let us quickly code this. Okay, I just comment this piece of code. And comment this. Read the input starting from and go up to number. Check if n modulo division ii, if it is 0. If the remainder is 0, print what? Print ii. Makes sense? Understood. We don't need this statement for now. And let me run this. Yes, 18. These are all the factors of it. 1, 2, 3, 6, 9, and 18. What about 7? Sorry, 7, just 1 and 7. What about 25? 1, 5 and 25 are the factors of 25, right? Using this program, you can find the factors of any number, correct? So 125. So these are all the factors of 125. All right, excellent. Let's move on. The other way of achieving this is to just limit your iterations to n by 2. How does this work? Let's go back to the same program. I'll run this program for an input of 100. Observe the output, right? I run this program for 1000. Observe the output. The key observation here is that focus only on the last two, right? After 50, that means between 51 and 100, there is only one factor. That means once you cross half of the number, there won't be any factor except the number itself. Look at this example. Focus only on the last two factors I said. What is half of this number? 500. So from 501 to 1000, there will be only one factor, which is the number itself. Look at your iteration. How many times does this execute for an input of 100? This iteration goes for 100 times, or of course 101 times to be more precise. How many times this loop iterates? If the input is 1000, this executes for 1001 times, correct? Out of which 500 iterations are waste. Because we already know there is no chance of getting a factor once you cross half of the number except the number itself. That's what I have been showing you here, correct? Still, the way you have written the code executes 50% of the times unnecessarily. To avoid that, what we do is we just allow this loop to execute only up to 50% of the input, meaning up to half of the input. What is half of this? 50. So execute your loop only up to this so that you will see all these things printed. But only thing that is not printed is 100. Okay, we'll take care of this as an exceptional case and we'll print 100 separately later. What if the input is 1000? We just go up to 500 and print all of this and we'll take care of printing 1000 separately. Make sense? But what is it we have achieved if we do this? You are reducing the number of iterations by half, which is a big benefit. Okay, from the performance point of view. All right. So if I run this same program for an input of 100, what you get is every factor of 100 except 100. But we're almost there, but we also want to see 100 in the output. What if I run this same program for an input of 1000? As you see here, you get every factor of 1000 but except 1000, except the number itself. To print the given number itself, you don't need an iteration, right? You can directly print the given input as finally. So that is how you can print all the factors. But how? Once you come out of the loop, continue to print n, which is a user input. One time print. This one. It's outside. Pass 100 as input. As you see, after 50, you also see 100 coming out. in the output. Run this for 1000. You see, after 500, so you did not really continue your iterations, 500 extra iterations, right? Unnecessary iterations. You stopped here, and then immediately you decided that, oh, there is one more factor because every number is factored to itself, and you have printed that over. All right. This is how you can optimize your code by reducing the number of iterations but still producing the same output. All right, let's jump on to the program. Now, hope you understand why the second approach goes up to half of the number, correct? And since you have to print the factor, you have to check whether the remainder is zero. And if the remainder is zero, you're going to print it out. And if you can, yes, I would like to also run this program for an input of 1, right? And 1 is factor to itself, and since 1 is factor to itself, we'll be seeing only 1 coming out, right? So that is how you can achieve this output. Okay, all right. How does this break help us, right? So one thing that I want to really talk about here is to develop a program which checks whether the given number is prime or not. This is very interesting, and all the factor printing and everything will help you out in this, right? So first of all, what is a prime number? When you have looked at the factors of 7, there were only 2. When you looked at factor of 6, there were there were more than 2, right? So a prime number is a number which has only 2 factors, and those 2 factors are obviously 1 and itself, nothing else. But if you look at 6, 1 and itself, apart from them, you also have other factors. So here 7 is called prime number, 6 is called a composite number, right? What about 25? Is it a prime number or composite number? Write down the factors of 25. As you can see here, there are 3 factors. Apart from 1 and itself, there is a factor. That means 25 is a composite number. What about 11? What are the factors of 11? 1 and itself. So this becomes a prime number. All right. So finding the factors would help you now to decide whether the given number is prime or not. So you can read the number to be checked. Okay, it's a primality check. So you read the input into n, then how do I decide? One thing is very clear from all these examples. One is anyways factor to any number. One is factor of any number, right? So keep this aside. And you already know 7 is every number is factor to itself. Keep it aside. Okay? Ignore 1, ignore the number itself. Now, look at prime. What is a prime? There are no factors other than 1 and itself. That is nothing but prime, correct? So that is what I'm going to check now. Start with 2 and I need to just check if the given number has any kind of factors. And I know that after crossing half of the number, there won't be any factor except itself. And I anyways know that the given number is factor to itself, so I need not count for that. So I'm going to run a loop from 2. Why 2? Because I know 1 is factor to every number. I also know that the number itself is also factor to itself. So what I'm going to do, I'm going to continue this loop starting from 2 but not 1. Keep that in mind always, right? Why? I'm just checking whether 2 is factor of 7. It is not. Can I immediately decide and say that yes, since 2 is not factor of 7, 7 is a prime? No. Take an example of 9. When you divide 9 by 2, remainder is 0. Can I immediately say 9 is prime? Not really. I've checked with 2, but I need to also check with next number 3. When I divide 9 by 3, remainder is 0. That means it is a composite number. Okay, makes sense? Take an example of 25. I can check whether 2 is a factor of 25. It is not. Check with 3. 3 is also not. Check with 4. 4 is also not factor. Check with 5. Yes, 5 is factor of 25. And stop there. Don't go with 6, 7, 8. There is no need in fact. Up to half of the number. You need not go up. You can skip all this because here itself you can take the decision that 25 is not a prime. Hence, at any point of time, when you divide the given number with the current value of I in the range of 2 and half of the number, what you can do, you can just break. Why? I need not go and check for rest of the numbers. I can immediately confirm that the number is composite. How can I say that number is composite? Because II has become the factor of n. How can I say that? Because it left the remainder as 0 when I did the division between those two numbers. That means except 1 and itself, there is some factor of n. Hence, n cannot be a prime number, right? That's what we're doing here. All right. Now, there are two possibilities to come out of this loop. What are those? One thing is II has completely iterated over all the possible iterations and you came out. What does it mean if that is the case? Say, for example, look at this. II becomes 2. You divide 7 by 2. Remainder is 0? No. So then what happens? Next iteration. So you decided that 2 is not factor of 7, but you cannot take a decision yet. Look at next number 3. You divide the number 7 by 3. Remainder is non-zero. Next. Do you have to go with 4? Not really, no. Because 7 by 2, half of the number if you go, that is enough. As I said, I have given you why, a reason for that, right? So 7 by 2 is just 3 point something, but anyways, it is integer division. So you stop over here. So you did not go with 5. You did not go with 4. Stop there. And did you find any factors of 7 in between in your journey from 2 to half of the 7? No, you did not find any factors. Then you can decide that the number is prime. Take an example of 9. Yes, you start with 2. Divide 9 by 2. Is the remainder 0? No, it is not. What we have confirmed is 2 is not a factor of 9. Okay, but I cannot immediately decide if 9 is prime or composite. Go to the next number because I have to go up to half of the number, which is up to 4 integer division at 0. I have to check all these 3 values. I completed 2. Look at 3. check with 3. 9 when divided by 3, remainder is 0. When the remainder is 0, I needn't go and check with the rest of the numbers. Why? I can immediately decide that 9 is composite because 3 has been a factor of 9. I can stop over there. So that is where this break helps me to stop the leftover iterations and take a decision immediately. However, as I mentioned, there are two possibilities to come out of this loop now. One is because of break, because break will also terminate the state iterations and get the control out of the loop. The other case is that this loop has exhausted, meaning it has executed all the iterations and finally it came out. But you need to differentiate between these two cases. For that, what you can do, generally people do is they take a flag, they um, set it to true or false, up to them. It is up to you, right? So now you can just, before you break, you can change the value of flag to different value than what it has been initialized with. Now you can check the condition once you come out of the loop. Hey flag, what is your name? What is your value? If it is still true, what does it mean? If the flag value is still true, what does it mean? That means program control has never gone into this body. How can I say that? If the controller had gone into this body, flag value would have been updated to false, but still it is true. That means it is left with the same value that I have started with. That means I have never entered into this. That means I have never found a factor to n between the range of 2 to half of the number itself. Then what can I conclude? Say that n is prime. Else, what does else mean here? Else means that flag value is false. When can the flag value become false? Only when you find a factor other than 1 and itself, right? So then I can immediately say n is composite. That's all. Let me run this program for you. Comment out this program. And this. So let us try with 11. Yes, 11 is prime. Very good. Let us try this program with 6, which is a composite. Yes, 6 is a composite. What next? Let us try this with 1, 1, 1. 1, 1 is composite. How? Divide this by 2? No. Divide this by 3? Yes. 3 times 3 is 9. 2 is a remainder. Then 21. 21 can be divided by 3 evenly, leaving the remainder 0. So 3 is a factor of this. That means apart from 1 and 1, 1, 1, there is a factor found in between. So 1, 1, 1 is composite number. Perfect. What about 25? 25 is also a composite number because 5 is a factor of 25 other than 1 and 25. So it is a composite number. What if the input is 17? 7. Sorry. 17, which is a prime number. Yes. So this is how your program can now decide whether the user given input is prime or composite. So this piece of code is enough for you to decide whether the given number is prime or composite. How does this work? I need to first differentiate between two things. One is because I can come out of this loop for two reasons. One is this loop has executed completely, right? And that's the reason because the loop condition is false, the range has exhausted and I come out. When does it happen? Only If the n value is prime, that happens. That means you never entered into this situation. Why? You did not find a factor of n. Then flag will remain as true. And that's the same thing that I'm checking. Did the flag value change in between during these iterations is what I'm checking. If it did not change and if it was with the same value that I have begun with, I started with, I can immediately say that it's prime number, n is prime number. In case it has changed because of this break helps me to skip the rest of the iterations. Otherwise, ideally, I should go up to half of the iterations. No, half of the iterations of 25 is 12. But because of this break, I can skip all of these iterations. That is where break helps you here. This is a practical example where break is useful in reducing the number of iterations and terminate the loop iterations in between and come out and then decide what to do next. All right. This is a program to check whether the given number is prime or not. Make sense? Let us jump on to the list of programs. The next one is to print prime numbers up to n. Interesting. How do you print prime numbers up to n? So, what does it mean? Say n is 10, input is 10. What are the prime numbers up to 10 is a question here. One is neither prime nor composite. Leave one aside. Keep one aside. 2 is a prime. 3 is a prime. 5 is a prime. 7 is a prime. And after that 11 is a prime. But you want prime numbers up to 10 only. So these are the prime numbers that your program has to print now. Make sense? So keep this code as your reference because the same piece of code we are going to tweak for multiple times to write different varieties of programs now. So this is a skeleton is what you may think or you could think of. This is what this piece of code can decide whether the given value is prime or not, right? Now, what I have to do to print all the primes up to given number? All that you need to do is to just generate the natural numbers. 2, 3, 4, 5, 6, 7, 8, 9, and 10. What are these? These are nothing but the natural numbers starting from 2 up to the user given n value. Okay, but not all of these are primes. How do I decide? That is where already written code will help you out to decide whether the current value of your iterator is a prime or not. If it is prime, print it. If it is not prime, skip it, go to the next number. All right. So all that you need to do is you need to generate the numbers starting from 2 up to user given input. How do you generate the number starting from 2 up to user given input? Okay. I'll use something. What is the range? Start from 2 always. Why? 1 is neither prime nor composite. So the smallest prime number is 2. Start from 2. Go up to what? N plus 1 because it is exclusive. Okay, all right. But what is what I need to do? Whatever code you have written so far, bring it into the scope of outer loop. Why? I'll show you the tweaks. So n value is not going to be entered by the user now. Then what is n value? It is nothing but jj. Why? When jj is 2, your job is to check whether 2 is prime or not. When jj is 3, you need to check whether 3 is prime or not. When jj is 4, you need to check whether 4 is prime or not. When jj is 5, you You need to check whether 5 is prime or not. That is how JJ value keeps generating, keeps changing, starting from 2 up to user given input up to 10 in this case, right? So every time whatever the current value of JJ, you need to decide whether it is prime or not, and that's all. You have the code here, but you have to print only primes. So if it is composite, you can leave it, right? So you can just remove this. You don't need this for this piece of code, right? And that's all. That's all you need. What you have done. This is some piece of code that you have already written for checking whether the prime or given input is prime or not. All that you have done is you have just wrapped that code around with another loop which keeps generating the numbers from 2 up to user given input. Every time the value of the loop variable, outer loop variable, is what you need to decide whether it is prime or not. So I just simply assigned it to n so that rest of the code is in place. Let me go and run this program for you. Sorry, I need to read the input also, no? So I need to ask up to what you want to print the prime numbers, right? I did not read that input. Sorry about that. I'm going to read it now. So enter the maximum limit. So I want to read it into some other variable like m or some. All right. Now j should go up to m. So end value is m plus 1. And that's all. Say I want to print. Oh, sorry. Somewhere. Oh, sorry. I need to just comment on this. Up to 10, what are the prime numbers? 2, 3, 5, and 7. Now, using this program, you can print prime numbers up to anything, 100. See, these are the prime numbers up to 100. 2, 3, 5, 7, 11, 13, 17, 19, 23, so on and so forth. The closest prime number to 100 is 97 according to this. Yes, these are the prime numbers up to given limit. And if you want to print prime numbers up to 1000, yes, of course, you can try it out. And these are the prime numbers up to 1000. Well, quite simple. Once you know how to check whether the given number is prime or not, all that you need to do is the entire piece of code, you need to wrap it around, wrap it under another loop. And the job of this loop is to keep generating the natural numbers 2, 3, 4, 5 up to user given input. And your job is to just make use of the existing code and check whether the current value of j is prime or not. If it is prime, then only print it. All right, as simple as that. Let's move on to the next one. The next one is to print primes between m and n. That means now user is going to read two inputs. For example, if the input is 100 and 200, there are two inputs that you need to read. Or I would say 5 and 10. Okay, for you to just understand first. The output should be 5, 7, and that's all. What are the prime numbers between 5 and 10? Just 5 and 7 only. So this is output. And if the input is 1 and 100, then of course you have to print all the prime numbers between these two numbers. Right? If the input is 500 and 1000, you have to print all the prime numbers between 500 and 1000. So that is expectation. And of course, as I said, the same piece of code would help you out again. How? I'm going to copy the same piece of code which would check whether the given number is prime or not, and What I'm going to do here is I have to read two inputs, no? So I'll read the user given input. Okay. Enter the lower limit, I will say. Lower limit means what where to start. Okay. I read it into LL. LL is a lower limit. I'll also ask for upper limit. Upper limit is UL. Yes, well. Now, what is it you need to do? To print prime numbers up to given limit, what you have done? You have used a loop. And this piece of code is more appropriate to use here. How? Because it's just a change to earlier program. How? Instead of starting from 2, you know the lower limit. User has given that. Start from there. You know the upper limit. It is UL. So upper limit is also inclusive. So plus 1 is required. You are done. Run this program. Lower limit is 10, upper limit is 50. What are the prime numbers? Sorry about that. There is some mistake I did. Okay, I will comment on this. Input is 10 and upper limit is, sorry about that. Where is it? Line number 35. I'm not considering it as integer or what? Line number 35 is this. What's wrong with it? Enter that lower limit. Okay, I'm converting it into integer only. Enter the upper limit. Okay, so I did not. Okay, sorry. I got it. So I need to pass the input properly. This one and this is the one. You see that? What are the prime numbers between 10 and 50? These are the prime numbers between 10 and 50. Your program is able to tell you now. Run this program one more time. I want to know the prime numbers between 101 and 300. Oh, sorry, every time I'm making the same mistake. Sorry about that. You can achieve this also, but the way I have written the program now, that's a different way to read the input. You see, these are the prime numbers between 101 and 300 inclusive, right? See how simple it is, right? So what did you do? You taken the same piece of code that you have written to print prime numbers up to given limit and just a small change order. Instead of starting from 2 always, you have started from lower limit and you go up to upper limit. That's all. And the current value of JJ you are treated as N, which is to be checked whether it is a prime or not. Only if it is a prime, you are printing it. As simple as that. All right. Well, this is how you can print the prime numbers um, between two given limits. So these are the three programs that we have discussed so far. The next one is to print first n primes. What does it mean? All right. Think of it. What does first n primes mean? Okay. Input is 5. That means you are supposed to print first five primes. What are those? 3, 2, 3, 5, 7, 11. So user asks for some certain number of primes to be seen, to be printed on the screen, and you have to just print that many. Here 5 is not the range, remember, range is different. If you treat 5 as a range, you have to print prime numbers up to 5 only. But this is not the range, this is a count. How many is what user is telling in this context. And that may go up to 11 or 12 or 1000, we don't know, right? So if the input is 100, you have to print first 100 prime numbers. It's not up to 100. First 100 prime numbers you need to print. What if the input is 10? If the input is 10, you have to print. How many print you have printed now already? 5, no? You have to continue this. 17, 19, how many? 1, 2, 3, 4, 5, 6, 7, 8, 23 and 29. Yes, this is the expected output if the input is 10, because these are the first 10 prime numbers. All right, how do you achieve this? Right? How do you achieve this? You don't know the prime number up to the range that you have to go up, right? So what you need to do is, you know the smallest prime number. So you start your loop from 2, keep generating the natural numbers, keep checking the current value of your variable, loop variable, whether it is a prime or not. If it is a prime, print it immediately and also count it. Once you print 2, increase your counter to 1. Once you print 3, increase your counter to 2. Once you print 5, increase your counter to 3. Once you print 7, increase your counter to 4. All that you are doing is how many primes I have already found and printed is what you are keeping track of. The moment your counter reaches 10, which is a user given input, you can stop over there. That means, because why you can stop there? Because you already found user asked number of prime numbers and you can stop over there. How do I do this? Right? So as you see, I can probably use this last piece of code to achieve this. And how does it happen? There is only one input here again, remember, okay? And first of all, let me uncomment this piece of code. Then enter the count of primes. How many primes you want to see is what you are asking. And read it into C, right? And start. You cannot go with range here. I'll use a while loop over here. While, what is the condition? Count is less than C. C is what user is looking for, that many number of primes. Count is what you have already printed. So far, 0. You did not print anything, that's why. Once your count matches with C, you are done. Okay, then what? What should I do here? And what you should also do is, you need to take, you need to keep generating the numbers, no? Or, yeah, that's fine. As long as your counter is less than C, what you can do is, you can start with number as 2, because you know 2 is the smallest prime number, right? And you just check whether 2 is prime or not. So you know how to check whether n is prime or not. Just assign num to n so that rest of all will be taken care. Okay, what if it is prime? What if n is prime? Okay, print n. Not only that, increment your counter. increment your counter. That's what I said. So count is equal to count plus 1. This is how you will keep maintaining the track of how many primes you have already printed. Okay. Whether or not you have printed the prime, make sure you have gone to the next number. Why? Because I said you have to keep generating the natural numbers so that every natural number you are going to check up to you reach this counter. So number is equal to number plus 1, right? So again, that new number value will be assigned to n, and all this happens. And but remember, every time the flag value has to be starting with. That is very important thing to keep in mind, because every time you start with a fresh number, you have to assume that to begin with you need to assume that it is a prime number. That's why you have to every time inside this while loop every time you have to initialize it. Makes sense? And that's all. Where is that in? Okay, sorry, I am just giving you some examples, but I'm not commenting out that. So, well, let me run this now. I want to see first 10 times. These are the first 10 times. Count them 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's all. I want to see first 100 primes. I don't know up to what I have to go, but I'm able to manage the program. See, the 100th prime number is 541. Now I can see the output and I can tell you, right? So you don't know that you have to go up to 554, 541 or 29 or that's the reason you are not relying on that, right? You are maintaining a counter. Now I have just changed that the outer loop to while, which is more convenient in such cases, right? And that's all. So what did we do? You read the input, ask the user how many prime numbers you want to see on the screen, and start with your own counter, which is 0, and start with the smallest prime number, which is 2. Repeat the process until you are yet to print some more primes to achieve the goal of the user, right? And assume that n is the input, right? And you know how to check whether the given number is prime or not. Once you find a prime, not only printing, but also you make sure you increment the counter so that eventually this condition becomes false. And once this condition becomes false, there is nothing to do for you. However, before you jump on to the next iteration, make sure you are going to the you are going to check the next number in the prime in the natural number series. That's why you have to increase the counter. And this number up to what it will go, it depends. There is no any limit because you are not using num in your condition anywhere. That is where you can achieve what how many ever numbers user is asking for, that many numbers of number of primes you can print and you can achieve it, right? You want to see the first 200 prime numbers? Yes, these are the first 200 prime numbers. Make sense? Let us jump on to the next one. The next one is to print nth prime number. Quite simple if you really understood the earlier one. I don't want to see all the first n primes. I just want to see only the nth prime number. That's all. Right? What will you do? Every time you find a prime, don't print it. Don't print it. Just print it once you come out. So, but remember, yeah, here you need to print n, of course. It's n, yes, correct, or in num. Anything is fine. You can use num, okay, because num is what is outside the loop that you have defined, and we should be able to access it. Okay. And okay, one more thing. Num is incremented one extra time. So ideally we should print num minus 1. Okay, I'll show the same examples that I have executed in the code for. So if you look at it, right, what is 10th prime number? 29. So all that I need is just 29 if the input is 10. Yes, 29, right? I don't want to see all the prime numbers, all the first 10 prime numbers. I just want to see only 10th prime number is what I'm asking. And what about this? I want to see the 200th prime number. Okay, what is expectation? It is just 223. Oh, sorry, it has been printing this way now. Sorry about that. 1223 is a 200th prime number, and that's what you see here. And what is the 100th prime number? It is 541. So I go ahead and run this program. What is the 100th prime number? 541, as you see here. So a small tweak to your program will print just nth prime number, but not all the n prime numbers. So instead of changing this, I will just keep it as it is so that you can compare them easily. But I'll comment out all this code. This is to print first n primes. This is to print only nth prime. So if n is 10, the expected output is 29. Of course, you can decorate the output according to your will and wish. Here, what you can do is you can say n minus 1 is okay. Um, C the prime number. Okay, let me run this for you. I'm asking for 10th prime number. It says 29 is 10th prime number. Yes, 29 is 10th prime number. So this is how you can write some meaningful code, and you see everywhere I'm using break statement. That's the key here. Why do you need extra control over iterations? These are the examples. Every program that I'm showing here uses break, right? Why? Because you can skip the leftover iterations or the remaining iterations of a loop and come out because they're not useful to you. You can decide something and you can quit out from the loop. That is where break helps you. And such so many varieties of programs is what you can write if you know these things. All right. The next one is to print the count of given prime number. You have to find the count of given prime number. What does it mean? N is 5. 5 is what really? Keep writing the prime numbers. 2, 3, 5, 7, 11, 13, so on and so forth. Treat this as first number, second number, third number, fourth number, fifth number, and sixth number, right? Something like that. Now user has entered 5. 5 is a third prime number. So user gives you some number which is a prime number, preferably or hopefully, okay? And you have to find its position in the prime series. Understood? That is a requirement. What if n is 13? You know, 13 is sixth prime number. So you should print that 13 is sixth prime number. Okay. So user gives you some prime number and you need to decide what is its position in the prime series. That is how this program is different. So ultimately, when the input is 5, you have to print 3. When n is 6, you have to print 13. That is expectation from this piece of code. How will you achieve this? Again, the key is to check whether the given number is prime or not, right? And to check whether the given number is prime or not, and you have to keep counting. What look at this, you'll get an idea. You have to check what is the position of 5 in the prime series. To understand that, you need to again start from 2. And once you find a prime number, you keep counting. Once you find a prime number, you keep counting. Once you find the prime number, you keep counting. And you reach the user input. That itself is your answer. Whatever is there in your counter, that itself is your answer, because that is the position of the user given prime number in the series. Make sense? I'm going to copy this piece of code and show you how to achieve it. Enter a prime number. And I call it as PM. Okay. I need a counter, I need number to start, and as long as number is less than or equal to PM. User has given prime number, now I have to reach that. I have to start from 2 and I need to reach user given prime number. If user given prime number is mean if 5, if it is 5, I need to go up to 5. So number starting with 2, it has to reach user given input. Again, same thing now. You have to check whether the current value of num, right, is a prime number. If it is prime, what to do? Don't print, right? Just increment the counter. That tells you the position, right? And number equal to number plus 1, anyways, you have to do this. Now print, this is PM, user given input, is what is its count? Your count is maintained in count. Okay, that's all. What did we really do here? You read the user input, which is a prime number, then start, the 2 is the smallest prime number, and you need to maintain the, you need to count from 2 also, no? 2 is the smallest prime number. So you start from 2, you keep generating the natural numbers 2, 3, 4, 5, and you do this until you reach the user given input. Every time you assume that the current loop variable is a number itself to decide or to check. If the user current value of n happens to be a prime number, increment the counter and just move on to the next number, whether or not the current value is prime or not, just keep moving to the next number. This is how you keep iterating. Finally, count is the one which tells you the position of your prime number. Let me run this program for you. I need to comment on this. Run this program. Say, what is 5? What about 5? Sorry, 11 is fifth prime number. Okay, this is behaving differently. Sorry, I need to adjust something. Let me look at it carefully. Sorry, this is what it is executing. Sorry about that. I need to comment on this code. No, all right. Let me run this once again. Yes, enter the prime number. It's so 5. Yeah, you see, it says 5 is a third prime number, which is perfectly right. Yes, 5 is a third prime number. What about 97? I don't know if you have observed. 97 is a 25th prime number. Yes, 97 is 25th prime number. Okay. Uh, Before this, I have asked you to print prime numbers, first 25 prime numbers, right? When I ask you to print first 25 prime numbers, oh, sorry, this one. This is 97. 97 is 25th prime number. You keep counting this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So 25th prime number is 97. So for this program, what I have asked is, please tell me the position of 97 in the prime number series. It says, yes, it is 25th prime number. Perfectly fine. All right. Well, um, this is how you can use break statement to terminate a loop execution and continue with the rest of the statements in the program. All these examples use break statement and in a meaningful way, and in a practical illustration, I have shown what varieties of programs you can develop just around prime number series. Interestingly, every program is different. Every program is different, right? And every program uses break statement. All right, perfect. There is also one more which is called continue statement, which is also to have more control over iteration. I'm going to quickly cover that so that you'll get an idea. So what is continue? What is continue? So let me simply write some piece of code here. Okay, look at this piece of code. We're quite simple, and the output that it produces, right? If I execute this, it is just 1 to 10. It prints natural numbers up to 10. Yeah, 1 to 10. Perfect. Now, what if I don't like 3 and its factors? What I can do is I can just check. Hey, are you factor of 3 or multiple of 3? If so, just continue. What does this continue do? It will just skip the rest of the code in the loop, and it will allow the control to go to the next iteration, right? So in such cases, this print statement won't get executed. Let us understand how this works. I starts with 1. Check this condition. When 1 is divided by 3, is the remainder 0? No. So continue won't be executed. So 1 will be printed. Then I becomes 2. When 2 is divided by 3, will the remainder be 0? No. So 2 will be printed. I becomes 3. When 3 is divided by 3, will the remainder become 0? Yes, of course. Then continue. This continue allows the program control or execution control to go to the next iteration where I becomes 4. Again check. 4 when divided by 3 with the remainder 0? No. So it comes and prints 4. So 3 is what we have skipped. But still we continue to iterate with the rest of the iterations. That is how if you want to skip certain iterations, if you want to skip some portion of the code in a loop from execution, then you can use continue statement along with some condition. If you run this program, this won't print 3, this won't print 6, this won't print 9. You see, 3 is not there, 6 is not there, 9 is not there. You see, that is how continue statement can be used to skip certain portion of a loop and continue with the next iteration. Right? Interesting? Yes. How do we use continue with while loop? That's what I'm going to show you now, because it is very, very important for you to understand what is the key difference when you use continue with while. So if I have to go with this, I need to start like this, no? While I is less than or equal or less than 11. What to do? Remember, um, you have to continue, right? And remember, since this is a while loop, you have to yourself take care of incrementing your loop variable to the next number. So say, for example, you have written this, right? What is your expectation? Okay, I'll just comment on this piece of code. Hmm. IA starts with 1 less than 11 true. Okay, 11 mod 3. Sorry, 1 mod 3. It is not 0. So 1 will be printed. I becomes 2. 2 mod 3, not 0. Remainder. 2 will be printed. I becomes 3. 3 mod 3 is 0. Now continue. No, this continue will go back, take the control back, but II will remain at 3 only. So it continues to process 3 only, because it is a different story when you use range with for, because when you do continue, the loop variable will automatically go to the next number, to the next iteration, because the value will change. Whereas in the while loop, it is your job as a developer to also increment the loop variable before you use continue statement. So for you, just to show you, I'll show you what happens, right? You just print I. Okay. I'm not using II plus one explicitly before continue. Let me run this for you and show you what happens. You see, it keeps printing 3. This is what I was referring to, infinite loop. Infinite loop is something that executes forever. There is no end, because your loop condition remains true forever. So I'll restart this. Okay. Now go back to your code. So who is the culprit now? The way we have written the code, right? So what you need to do is you need to make sure you also increment the loop variable explicitly when you are using continue in your while loop. For loop, you need not take care. Automatically, the range function will generate the next number, and that is how loop variable will automatically move on to the next iteration with a different value. Whereas while doesn't do that automatically for you, because that is why you are maintaining the increment or decrement of your loop variable by your own, right? So that is where I have explicitly written this I is equal to I plus 1 before I use continue statement. Run this program. See, now 3 and its multiples. Well, keep this in mind always when you are using a while loop, and when you are explicitly using continue inside while, make sure you are taking care of changing the loop variable accordingly, so that eventually the loop condition will become false. All right. This is how you have to use continue, and continue also allows you to have more control over iterative structures. I have shown you it with both for loop and while loop. All right. And this brings us to the end of the session 8. And once again, for those who have joined late, I'm going to show you the website. This is the website. Make a note of it, technolearnit.com. And especially you can go to courses tab, and you can find out all the courses that we offer. And you can also get in touch with us in either of these channels, right? And subscribe to all these channels, and you will also get notifications. And the other thing, mainly the resources, whatever resources I've used in all these sessions, they have been made available here, where you can download them for free and practice them listen to these sessions again because they will be uploaded to different media, including YouTube, LinkedIn, everywhere. And you can listen to them. You can practice more and more. And if you have any questions, you can add comments and we will be happy to answer them. In addition to that, I would like to show you the YouTube channel Technolearnit. As you see here, once you subscribe, and this organization keeps posting the quiz questions on what we have covered so far in Python from all the earlier sessions. And this will help you to be in touch with programming and the concepts. And you can refer to these quizzes, you can guess the answer, and answers will be available there itself. And all the live sessions and everything will be available here. So you can make use of all this material and you can become better at programming, right? So with all that, I would encourage you to subscribe to all these channels, right? Mainly the YouTube channel and also the other Instagram, LinkedIn, okay, and X and everything. All right. So this brings us to the end of this session 8, and keep watching this space to have the session 8 material posted. And the next session would be date and time would be uploaded on the same page. And have an eye on this space to at this space. Okay, that's all for today, and take care. Happy coding. Thank you.